The Schwarzschild wormhole, also known as the Einstein-Rosen bridge. It was discovered by accident. In 935, Einstein and Rosen weren't hunting for tunnels through space. They were just trying to describe an electron using pure geometry. But the math handed them something stranger. A bridge connecting two separate regions of spacetime, folded together like paper. On paper, it looked like a shortcut. In reality, it's a trap. Here's the fact that changes everything. This wormhole seals itself shut faster than light can cross it. Light is the fastest thing in the universe. It still isn't fast enough. The bridge opens, stretches, and pinches closed in a fraction of a second. Anything inside gets crushed at the exact moment the tunnel collapses. Not maybe, not probably. The math guarantees it. There's a second problem, quieter but just as final. Even if you survive the pinch, the two sides of a Schwarzschild bridge may not connect to any universe reachable from ours. Some solutions link two separate exterior regions with no shared history at all. You wouldn't be traveling. You'd be erased from one reality and never truly arrive in another. So, the very first wormhole predicted by general relativity was already a dead end. 100 years of physics, and the very first answer was, it kills you before you notice. Let that sink in. Consider the timescale involved. For a wormhole built from a black hole with the mass of our sun, the entire lifespan of the bridge, open, stretched, collapsed, lasts a fraction of a millisecond. Light itself, moving at roughly 300,000 kilometers per second, doesn't have time to finish the crossing. Scale that up to a supermassive black hole, something like the 4 million solar mass giant at the center of our galaxy, and the bridge survives slightly longer. Slightly, not meaningfully. The geometry scales with mass, but the outcome never changes. Closure always wins the race against light. There's a reason this particular wormhole gets nicknamed the bridge to nowhere in some textbooks. Even setting aside the timing problem, the two mouths of a Schwarz bridge sit inside two separate black holes' event horizons. To use it as a shortcut, you'd already need to have fallen past a point of no return. You wouldn't be traveling through the wormhole so much as being consumed by two black holes that happen to share a geometric handshake. But physicists don't give up that easily. If the problem is the bridge collapsing, what if you just held it open? Traversable wormholes, the version science fiction actually wants. Here's the twist up front, stated plainly: nobody has ever built one, seen one, or found any evidence one exists. This entire category is theoretical. It lives entirely in equations. That honesty is the point, because what the equations say is still wild enough to matter. To stop a wormhole from collapsing, you need something pushing outward against gravity's pull. Ordinary matter can't do it. Every atom, every star, every planet only pulls inward. You need a substance with negative energy density, matter that, by the standard rules, shouldn't exist in any meaningful quantity. This isn't science fiction hand waving. Negative energy has actually been measured in a real laboratory, in a real experiment. It's called the Casimir effect. Two metal plates placed extremely close together in a vacuum, generating a tiny, real negative energy gap between them. The effect is genuine. The scale is not. Here's the fact that changes everything. The amount of exotic matter needed to hold open even a small human-sized wormhole is comparable to the mass energy of a star. Not a lab bench, not a warehouse. A star's worth compressed into a stable, controlled, negative energy shell around a tunnel through spacetime. We have detected negative energy. We have never generated it in any quantity that matters. That gap between real phenomenon and usable at scale is the entire reason traversable wormholes stay in the theory column. Here's the part that should genuinely bother you. General relativity doesn't forbid this. It just demands a price no known technology can pay. Break the numbers down further and the gap gets worse, not better. The Casimir effect in a real lab produces negative energy densities almost too small to matter, fractions of a joule across a gap thinner than a human hair. A stable human traversal wormhole throat needs negative energy density on a scale that would require converting a mass equivalent to Jupiter, or in some calculations, an entire star, into pure negative energy field, then containing it indefinitely in a stable configuration. That's not an engineering problem waiting for better materials. That's a difference of roughly 30 orders of magnitude between what we've measured and what the geometry demands. Some theorists have proposed shrinking the requirement instead of scaling up the technology, wormholes at the quantum scale, microscopic tunnels, a fraction of the width of an atom, needing only a whisper of exotic matter instead of a star's worth. Even there, the tunnel would be too small and too brief for anything, information included, to reliably pass through before it snaps shut. Shrinking the wormhole shrinks the price tag. It also shrinks the payoff to nothing. Morris-Thorne Wormholes, the blueprint that made theoretical mean something specific. In 988, physicists Michael Morris and Kip Thorne didn't just imagine a tunnel. They engineered one, on paper, designed specifically so a human being could survive the trip. No infinite tidal forces. No instant collapse. No radiation bath at the threshold. This is the wormhole every serious science paper on the subject actually references. It has a shape, a throat, a minimum radius, and a geometry chosen deliberately to keep gravity gentle enough for flesh and bone. It requires exotic matter threaded through that throat, holding it open against its own gravitational urge to collapse. Here's the escalating detail that matters. Thorne originally built this model as a favor. A friend, the writer Carl Sagan, needed a scientifically plausible way to get a character across the galaxy fast for a novel. The physics came first. The fiction followed the physics, not the other way around. That's unusual, and it's why this model carries real scientific weight instead of being dismissed as fantasy. Here's the fact that changes everything. Even in this best case, most survivable design, the wormhole still needs exotic matter with negative energy density threaded continuously through its throat indefinitely without fail. Remove that thread for even a moment, and the throat snaps shut. This isn't a one-time cost. It's permanent life support for a hole in space-time. Picture it, a tunnel that only exists because something is actively, continuously refusing to let physics do what physics wants to do. The moment you stop paying, the universe collapses the shortcut and erases the evidence. It's less a bridge and more a held breath. Morris and Thorne worked out the practical numbers too, and they're worth sitting with. For a wormhole with a throat roughly a meter wide, large enough for a person, small enough to sound almost reasonable, the tidal forces at the threshold need to stay below what a human body can tolerate, which the geometry allows in principle with the right shaping. Radiation exposure crossing the throat also needs to stay survivable, which again the model permits on paper. Every individual hurdle has a theoretical answer. It's only when you stack all of them together, negative energy, indefinite duration, survivable tides, survivable radiation, structural stability, that the design collapses from hard into we have no path to this, even in principle, with known physics. Thorne himself, decades later, has been careful to describe this model as a proof of mathematical possibility, not a plan. Lorentzian wormholes, the category that quietly contains everything we've discussed so far. Here's the reframe. Lorentzian isn't a new kind of wormhole. It's the mathematical family that all physically meaningful wormholes belong to, named for the geometry of space-time itself, where time and space are treated as fundamentally different, not interchangeable. This is the geometry general relativity actually uses to describe our universe. There's a sibling category, and it's a trap for the unwary Euclidean wormholes. These live in a different mathematical space, one used in certain quantum gravity calculations, where time behaves like just another spatial direction. Euclidean wormholes are mathematically fascinating and appear in serious physics papers, but they are not journeys anyone could take. They're calculation tools, not travel plans. Here's the fact that changes everything. Every wormhole capable, even in principle, of connecting two real points in our universe, Schwarzschild, Morris-Thorne, anything with a chance of mattering to a traveler, has to be Lorentzian. If a proposed wormhole isn't Lorentzian, it isn't a shortcut through space. It's a shortcut through math, useful for physicists, meaningless for anyone hoping to step through a door and land somewhere else. This is the sorting mechanism behind the whole category. Not size, not shape, not who theorized it. Whether the geometry even allows for a there to travel to. Everything we've covered so far has passed that test. What comes next stretches that test to its absolute limit. There's a third distinction worth naming because it comes up constantly in serious papers: static versus dynamic wormholes. A static Lorentzian wormhole, like the Morris-Thorne design, holds a fixed shape over time. The throat neither grows nor shrinks once it's stabilized. A dynamic wormhole evolves, expanding or contracting, and some versions can, under specific and narrow conditions, briefly stay open without needing continuous exotic matter, only a short burst of it. That narrow exception has become its own small research subfield. It hasn't produced anything traversable yet, but it's the closest the math has come to loosening the negative energy requirement even slightly. The Kerr wormhole, hiding allegedly inside a spinning black hole. Most black holes we describe are simplified, non rotating, perfectly spherical, mathematically clean. Real black holes spin. And a rotating black hole's geometry, described by the Kerr metric, does something a non rotating one never does. It avoids a singularity that's a single infinitely dense point. Instead, the Kerr solution predicts a ring singularity, not a point, a ring. And the math suggests that in principle, an object could pass through the center of that ring without hitting infinite density, coming out somewhere else in spacetime entirely. Here's the fact that changes everything, and it's the harshest one yet. Real black holes are formed by matter collapsing violently, and that collapsing matter itself is expected to seal off the ring's interior before anything could pass through it cleanly. The pristine, empty version of the Kerr geometry, the one where the ring stays open, is a mathematical idealization. Reality gets messier before you get anywhere near the ring. There's also the small matter of what waits just outside that idealized doorway, an infinite blue shift. Any radiation falling toward the ring gets compressed to effectively infinite energy right at the boundary you'd need to cross. Most physicists treat this as a closing statement, not a caveat. The ring, if it's a doorway at all, welds itself shut with radiation before you'd ever reach it. So the spinning black holes might be Wormhole's idea is real physics published in real journals, taken seriously as a mathematical curiosity. It is also, by the consensus of the people who study it, almost certainly not a door anyone or anything could ever walk through. Let that sink in. The most exotic sounding wormhole hypothesis is also the one physicists trust the least. Here's a number that makes the danger concrete. Real astrophysical black holes spin fast. Cygnus X -1, one of the first confirmed black holes ever detected, rotates at a significant fraction of the theoretical maximum. A spin that extreme distorts spacetime around the ring into something closer to a blender than a doorway. Add the collapsing matter from formation, add the accretion disk material most real black holes are still pulling in, and the clean ring scenario from the textbook diagram basically never occurs in nature. It's a beautiful solution to Einstein's equations for an idealized, empty, perfectly formed black hole. Real black holes are not idealized, empty, or perfectly formed. They're violent, messy, and still eating. If spacetime itself won't cooperate, maybe the shortcut isn't in space at all. Maybe it's in something even stranger. ER equals EPR. The idea that entanglement and wormholes might be the same thing, wearing different clothes. Here's where this gets genuinely strange and genuinely current. This isn't decades old theory. It's an active, unresolved research program from the last 15 years. ER stands for Einstein-Rosen, the bridge from 1935. EPR stands for Einstein-Podolsky-Rosen, a separate 1935 paper by the same author about quantum entanglement, the phenomenon where two particles stay correlated no matter how far apart they travel. Two papers, same year, same author, for 80 years treated as completely unrelated, one about geometry, one about quantum weirdness. Then, in 2013, physicists Juan Maldacena and Leonard Susskind proposed something that sounds almost too tidy to be true. What if every pair of entangled particles is secretly connected by a microscopic, non-traversable wormhole? What if geometry and entanglement are the same underlying fact described in two different languages? Here's the fact that changes everything. This isn't mysticism dressed up in physics vocabulary. It emerged from rigorous work in string theory and quantum gravity, specifically from studying how information behaves inside black holes. If ER equals EPR holds up, it means the fabric of spacetime itself might be built, at the smallest scale, out of quantum entanglement. Space wouldn't just contain entangled particles, space might be made of them. State that plainly, and it should stop you cold. The tunnel connecting two entangled particles, on this view, is real geometry, just utterly microscopic, utterly non traversable, and stitched into structure of the vacuum itself. You are right now sitting inside a universe that might be quietly wormholed together at a scale a trillion times smaller than an atom, and you would never feel a thing. This remains unproven. No experiment has confirmed it. It's a conjecture, actively debated, actively tested against other ideas in quantum gravity. But it's taken seriously by some of the most rigorous minds in physics, which tells you something the pop culture version of Wormhole almost never captures. The real frontier isn't spaceships, it's information. The idea grew out of a much older puzzle called the black hole information paradox. The question of whether information that falls into a black hole is truly destroyed, which would break quantum mechanics, or somehow preserved, which would require spacetime and quantum information to be far more intertwined than anyone assumed. ER equals EPR is one of the most serious attempts to resolve that paradox without breaking either theory. In 2019, researchers even ran a simplified experiment on quantum processors, not detecting an actual wormhole, but simulating the mathematics of one, moving quantum information through an entangled system in a way that matched wormhole like predictions. It made headlines as the first wormhole created in a lab. Read past the headline, and the honest version is quieter. It was a simulation of the equations run on ordinary quantum hardware, not a hole in spacetime. Useful. Real science, not a doorway. Which brings us to the gap between what wormholes are and what we've been sold. Pop culture wormholes versus real physics. Time to settle the score. Science fiction needed a shortcut, and wormholes were the obvious tool. A glowing ring you fly through, a tunnel with visible walls and swirling light, a door that opens on command and closes behind you like a curtain. It's a great visual. It's built almost entirely from imagination, not equations. Here's the fact check, one item at a time. A rotating ring gate you step through with no ship required. That's a storytelling device, not a predicted structure. Nothing in general relativity produces a stable walk-through doorway shaped like that. A wormhole you can dial to a specific destination, punching in coordinates like a phone number. General relativity says nothing about controllable, targeted connections. The math describes whether a tunnel can exist, not where its far end lands. A wormhole that appears briefly, without any exotic matter holding it open. The equations are blunt on this point. Without negative energy threading the throat, it closes before anything gets through, full stop. What science fiction gets right is smaller and more interesting than the special effects suggest. The core concept, a shortcut connecting distant points by folding spacetime rather than crossing it, is genuine general relativity, dating back to 1935. Real physicists really do study whether some version of this could work. Real physics really does require exotic matter and negative energy to prevent collapse. The film Interstellar leaned on Kip Thorne himself as a scientific consultant, and its wormhole visualization was built from actual gravitational lensing equations, not just concept art. Here's the honest boundary stated once clearly. The concept is real physics. The mechanism, glowing rings, dial a destination controls, casual survivability is invention built to serve a story. Real wormhole physics is colder, harder, and far less convenient than any script would allow. And that's not a disappointing conclusion. It's the more interesting one. Other franchises take more liberties, and it's worth naming the difference plainly. Wormholes used as instant, no-cost teleportation between star systems, with characters strolling through unharmed and unbothered. That's pure narrative convenience with no equation behind it. Wormholes that open and close on a fixed schedule, like a train timetable. Nothing in the physics predicts periodicity like that. If a natural wormhole existed and briefly opened, there's no known mechanism that would make it reliable or repeating. The pattern across nearly all of these stories is the same. Fiction keeps the awe and discards the cost. Real physics keeps the cost and makes you earn the awe. So, why has no one ever seen one? Here's the recap, all 7 in one breath. The Schwarzschild wormhole, mathematically real, physically lethal, sealing shut before light can cross it. Traversable wormholes, theoretically possible, requiring negative energy at a scale no technology can produce. Morris-Thorne wormholes, the survivable blueprint, permanently on life support from exotic matter. Lorentzian wormholes, the entire family every real candidate belongs to, distinct from purely mathematical Euclidean cousins. The Kerr Ring, a doorway predicted by elegant math, almost certainly welded shut by collapse and radiation in the real universe. ER equals EPR, the possibility that entanglement itself is built from microscopic, non-traversable geometry. And pop culture wormholes, a real concept, wearing a costume built entirely from fiction. Not one has ever been detected. Not one photograph, not one gravitational wave signature, not one indirect trace in decades of increasingly precise observation. Some physicists have proposed indirect searches anyway, looking for the specific gravitational lensing signature a wormhole mouth would produce, distinct from an ordinary black hole's, or watching for unusual light curves from objects that brighten and dim in patterns an ordinary star can't explain. A handful of candidate signals have been floated over the years. Every single one, on closer inspection, has had a simpler, non exotic explanation. 0 for 0 decades running. Here's what it would actually take: a source of negative energy at a scale comparable to a star, engineered with precision, sustained without interruption forever. Nothing on Earth, and nothing we can currently imagine building, gets remotely close. That's the real answer to why science fiction had to invent the version with glowing rings and push button destinations. The real thing, if it's out there at all, doesn't perform for cameras. It sits in the math, technically permitted, practically unreachable, waiting on a form of matter we've only ever caught in a laboratory for a fraction of a second. Maybe that's the more unsettling ending. Not that wormholes are fake, that they might be real, permitted by the same laws that put a man on the moon and GPS satellites in orbit, and still completely permanently out of reach. The universe left the door unlocked. It just built the key out of something we may never hold. Think about what that means for the rest of the taxonomy you just heard. Every entry on this list obeys the same math that predicts orbiting planets, falling apples, and the bending starlight astronomers have measured for a century. None of it is fringe science dressed up to sound respectable. It's mainstream general relativity taken to its logical, uncomfortable edge, the same equations, just pushed further than most physics classes ever bother to go. That's what makes wormholes different from most science fiction staples. Faster than light travel by simply going faster is flatly forbidden. Wormholes were never forbidden. They were just priced out of reach by physics that doesn't negotiate and doesn't care how badly we want the shortcut to be real. Not bad for stick figures on a rock.